Oh, it says it's working. It says it is working. Nice. And then one day I'll figure out how to make the YouTube chat good. Okay, yeah, I was up all night yesterday working on stuff. And now we're going to continue. I have my lukewarm coffee. A phone that's set to silent. And let's see where I left off. So basically what I've been building is the directory layout for the window manager laid down in the YouTube video. So here we can see I run the window manager as it is. Currently I have these two. Data donkey is missing a binary, but the B term has everything working. If I hit this, we end up directly in root SD home, which is what I want to be the default. For the where your shell starts. And the way this works, I mean, I guess we could actually just view this in here. The way this works is we have this test data. Oh yeah, I should close Discord, shouldn't I? For the stream. Got people messaging me. If I output that. So we have this tabular file, which contains, in this case here, we see, oh, there's going to be bterm.pb. There's the name of the program is bterm. So the binary here is the unique identifier, bterm.pb. And then we have, you know, a human readable name, the basic terminal program, and then the parameters as well, which is, so dot here is referring to, when we start the window manager, we say, here's the directory, which is the, I guess, config directory for the window manager, the overarching thing. And then here's the root directory of the entire system, essentially, or as far as you're concerned, the entire system, which is basically the parameter root. So the bterm parameters here is that root directory, and then we also say, okay, but I want you to go directly into SD domus. And you see we can have data donkey 3 here, but it says missing parameter, or missing binary, sorry. And then also what's cool is if we look in the R arcs here, this bterm.pb directory was automatically created. There's nothing in here yet. But it gets automatically created if it doesn't exist and then passed to the program. So, I mean, with that, let me actually double check my notebook with my to-do list. Because I created in here a to-do list. And now I've done the things. Yeah. So the next step is kind of, well, we should probably, I need to, right now if I hit caps enter, nothing happens. So I need to fix that. And there's also a rendering problem. Let me write that down. Yeah, so we have binary name. If that matches, we set this. Maybe we actually don't make a new program. Instead, we just start. Let's see. Maybe we just make the changes to the terminal that I want to make. That seems more obviously productive to me. Okay, there we go. I hit enter. I got the thing. We can launch it this way. We try to launch data donkey. Nothing happens. Now I want to fix this rendering error. You see the flicker. Oh, curious. Does it only happen on the most recent? Oh, of course, the resize. Yeah, the resize is triggering a rescale. Do that and then that. The problem is that when the window is created, the frame counter is at 0. And so then when we do our diffed rendering, let's see. I don't know, before there was this problem where one of the 2 frames buffers would be black and so it would flicker. And so I just put in a fix for that specific case. Okay, there we go. Problem solved. Now, I guess what I actually want to do is I want to exploit the fact that we now have this config directory for the terminal. And so we could easily do a we could have a file that saves that has the commands, like, you know, currently we have this guy up here. Oh well, actually in here. Serenum users will recognize this guy. I think I want to recreate something like this in the config directory for the shell. So I'm trying to remember, what should that well, what should that mean? That's a dumb question, but I'm trying to remember what people's complaints have been for the shell stuff. I guess, yeah, they want, I remember, I think Taylor's requested being able to run a program in here with predefined arguments, which I guess I speak about in the video as well. So, yeah. We could have this be in this new file, it'll be name a binary arguments. We have this config arc. I wish my brain wasn't so fried from being up yesterday. Would make it a lot easier. program this. So we get the files in config arc. And if the files match commands.txt, then set commands file and break. The reason we do this is because everything from after this open paren and this comma will be included in the assert failure printout. So we get our commands file. And then we'll read from it in a second. And I guess it's like line by line, so we can be tolerant of failures here in a way that's healthy. Let's try this first, just to see it. I don't know, a little bit disappointed in Brain FM. Maybe I need to go back to the lo-fi tracks. I think the plan is we get to feature parity in the new shell today. And it'll actually be better because I want to do history that's persistent across restarts. Okay, so let's run this thing. So, to begin with, the test data folder. We have our arc. Here's our bterm arc. Got nothing in it. So we run the shell with its giving its arc folder. And also, let's say, here is the top root. We get a new shell. But if we check what has happened in this folder, we now have a commands.txt file. Very nice. And of course we can close this and then run it again. Hi David, what's up? We run it again, we kill it again. Test arc btem, where's the file? What do you mean by made the C compiler? You compile the C compiler? Or did you make the C compiler to end all C compilers? I'm pretty sure that title was taken by CUIC. CUIC is of course the best compiler. I don't understand what you mean by made. And also what do you mean by Serenum compositor? Do you mean compositor as like image manipulation or as like X Windows thingy? Programming language compiler. We already have that. I mean, I'm using it. Oh, like Hyperland, I see. Well, yeah, I'm working on that right now. That's this thing. That's what this thing is. This is the graphics. You know, we even have cool error codes. So if I run, you know, look, here's the compiler running and saying, I don't have any args or whatever. So the next thing here is we're going to load yeah, do read entire file. Of course, this is in Unicode, so we have to convert it. Oops, what's up? Oh, monitor tripped up for a second. Looking for this. Then I want to split this into lines. Source code, everybody receives source code, not by email, but when you have our Serenum owner, when I do a release, I push, everybody gets new download links to the latest version. I mean, it's open source in the sense that there are no legal restrictions on the source code that is received. So, but it's not like, it's not a freebies kind of thing. How do I type in Latin accents? Do I have a custom keyboard? No. Instead, on this operating system, the tilde key, that's the key on a standard American layout. It's the key under the escape key. It's been a while since I tried it with an ISO keyboard, but I think the same should apply on a European keyboard. But you press that and then you press a key. So if I press just O, I get O's. If I press the tilde key, then press an O, I get the macroned O. So no custom keyboard required. How do you make a string or in Serenum? In Brabus, you mean? Like this? Unless if you mean allocating space for a string. Well, a string is just a slice of bytes, one of these. And so you allocate. In fact, well, you know, in this case here, let's say I have the name of the command here. I load the file, so I have all the bytes from the file. Then I split them into lines. This returns basically a spatium or a slice of a slice of bytes or something. Anyway, we're iterating through the lines. And then in Java, you'd be duplicating all these strings, which is not very efficient. Here we just say, I have the name, for example. It's going to be equal to lines. Well, let's say actually we have the current line, which is a string, is equal to lines 0. Then we advance. So we have this line. And then I say that the name is equal to line subscripted, just the first character. And then I want to extend this as long as there are spaces in front. Or as long as the next thing isn't a space, right? Because we're looking for this first thing on the line. And then what we do is we say, hey, command.name is equal to name. And we also trim the line, or we advance by name.m plus 1. Well, no, we just advance by name, like that. So I'm using this pattern for errors where we have an error string, and then if the error string is 0 in length, then you know it's good, so to speak. We're guaranteed to get a name from the command. Because there must be something on the line, otherwise our line split actually deletes it. Yeah, so the only error that can really happen, we can have a missing binary and a argument error. Serenum is a RISC-V system only. That's correct. No, there's no tilde sign on Serenum. Come back to me when you speak Spanish and you actually need it. And even so, I don't think anybody writing Spanish, I mean, you want like the tilde on top of the N, not on its own. So yeah, it's RISC-V only, because RISC-V is cool. We have our error string, and then what we do here, we need to pull the binary path. Hmm. Okay, I'm gonna be lazy here. Oops. Split by space. This is actually wrong, but it'll be fine, actually. Now what I want is it lookup path? Path string, yeah. Is it? I need to be more consistent so I actually remember these things. It's a byte, yes. If there are no elements, we just set the commands or the error string to be so if we do find it, we can actually set this so we have the And now what's great about this system is we can continue now, and when we just wrap every stage in its own, you know, if the error string has length 0. So if an error occurs at any point, we just skip processing that any further. And then the error can be reported later on. Well, okay, so you say that the tilde is a valid ASCII character, not having it available, it's going to bite you one day. I mean, that is true if we were using ASCII, which we're not. We're using clear text, which is a different encoding I made up. The programming language is called Brevis, and is of my own making. So yeah, the next stage is we need to process the arguments. There's some guy here, try program args, I think. This guy reports failure by returning a number of k argument that is not equal to the string args. I think that's it. I hate the YouTube chat window. I need to type stuff so that I can actually see the message. Going that custom does have its downsides. Yes, it absolutely does. We support Unicode as well, but Unicode is definitely a second-class citizen. Anyway, we ought to have our commands here now. I might actually just do this, and then we'll shadow it at the end here. Now I want to use these, and I think we're just going to initially print out like, hey, was this successfully loaded, or was there a load error on this command? Yeah, maybe I add them to the commands array, actually. Well, yeah, maybe. No, actually not. It's different enough. Here's what we'll do. We'll say, where is this commands defined? Up here. Whoops. So now here we can simply say if there's a user, if it's a user command, I think split command. Oh yeah, we should also check for duplicates. So I actually want to make this global. So I think that'll be useful for future reference. Like if something wants to list all the user commands. I also want to tuck this in here. And then we also here want to say we add all the commands to this commands list, and then we go over again, and we say what we want to say is, so if you had a user command that you name the same as a built-in, then that needs to be flagged as like, hey, this is name collision, so it's not going to run. What is at? At is pointer. So I have a pointer that points at or points towards a command. This is the thing that points at a pointer that points at a command. The motion is also left to right, right? So we start, the indirection is, we move through the things as we go left to right in the type. So we can have a spatium of pointers to groups of 4 commands. Percent is dereference. So post dereference. So this is a pointer, and this is saying, hey, go through, actually follow that pointer to the value on the other side. Whether that be, it could be writing or reading. So if CSJ has a user, oh, and I should say, maybe this is confusing as well. In Brevets, if you have a pointer to a struct and you use the dot operator, that actually offsets into the struct. So I can have a pointer and then I do pointer dot member, and it does the pointer arithmetic to go to that member. So now you produce a new pointer that points somewhere inside of the structure. So here we have a spatium, we subscript the spatium, which gives us a new pointer. Then we take that, your dot user gives us another pointer, and then we dereference it. And the reason it's designed that way is because there are no memory operations happening that don't have a visual percent in the code. So you can see all the memory ops happening at a glance, which is useful. So if it has a user and is not equal to this user, oh yeah, and then this is a downside, but we make choices. If you want to change a group of 4 U8s to a U32, the machine is a little endian, so you could do a pointer thing there, write it to memory, read it back in, or you could do the shifts manually. And the reason we have to dereference here is because a global, like a global by definition, is somewhere in memory, and so when we refer to it, there's a pointer to, and this is to adhere to that rule. So this is just saying like, hey, we're modifying this global, and that is somewhere else. Or we're re-accessing the global. Okay, so if all of this and strings equal if this is true, then we have found ourselves a name collision. Do I have errors as values? I don't know what that even means. But maybe. If I had to guess what you mean, maybe. Or probably yes. There's no language feature that's there to handle errors or something. I find that not to be very useful. Well, okay, let me refine that. Yeah, we don't have return error from function. What we do have is we have multiple return values that are strictly not tuples. They're made to be a little bit annoying. What this means is if you have an error, like you could either return a value that's like an error version of the thing you got, that's fine, that works. You actually don't want that to be the Rust thing because, well, in many cases, there's exactly. You have the OK thing, which you've seen me use on the stream. But Ryan Fleury has a really good article on handling errors, and I, until proven otherwise, think that that's probably true and mostly the best way how to handle errors. But I have yet to I haven't done enough stuff where I have a contrary opinion to that article. So I'm just doing my best to be more like what's described there. No option type. I really don't like option. I mean, option is actually far better than error in Rust. But yeah, I don't like option. The thing about option is you actually force control flow later on, which you don't want. You actually want like your code paths to sort of flow together. Ryan's article lays this out, but instead of having an option, you want like a dud type. Like that's what I've been doing here, for example. When we pass a command and it fails, we don't return none or something. What we do is, you have a user command and it just has this error string on it. And what that means is that a lot of the code can just work with these even though there are errors. And so even the user commands with errors can flow through the system and through the code the same way as everything else, and then a later system down the line can look at them and say, oh, there's an error with this one. And it greatly improves error reporting, I think. Because for any good system of errors where you report them to, like if you're not going to handle the error, you should just assert. And for that we have good asserts in the language, right? So you can assert, and then there's a nice stack trace and everything, so you can easily find it. And you actually want to assert as close as possible to the initial failure so that you can figure it out later. What's bad about what they do in Rust is extremely good at, okay, so everybody has the cult of like, oh, I can never crash, I have to return the error. So they return error types, and error types turn into other error types. And then when you actually crash, which you always do crash, you just crash way higher up the call stack. And now you've successfully deleted the information about what the actual problem is, so you can't fix it. Right? You like expect something to succeed, and then it's like, oh no, I failed. And that's all the information you have. Whilst if you actually assert, you assert further down, or the errors are a valid state of your program. In which case they're not errors in the same way. They're just normal code like everything else. In which case you shouldn't have an error type because you're doing something intentional. Like for example, you couldn't use Rust's error type if you implement like a compiler as library thing, because the compiler as library wants to return like a whole. The compiler as library actually wants to complete the compilation, return normally and say, okay, I didn't succeed in compiling this. Here is the list of errors in this code. Here are like, here's an array of structs. They all have information about where in the code there was this error, what was the error, detail strings, and that's too complicated to, that has to always be a bespoke system. So actually I'll link the article because it deserves mention. Was this the one with the train tracks? Yeah, here it is. The compiler does, well, it has an internal representation, and then I use that to emit textual assembly for x86 that I feed into GNU assembler, so I can build things that run on Linux. And for RISC-V, I emit machine code directly. But yeah, it goes through this intermediate representation, but it's a compiler internal intermediate representation. So it's not something you could target because it's, changes whenever it needs to change. Anyway, okay, so we have these things. I need to implement this do user command. Let's see, if I want to make this really good, I would do this. So this should be gray. This should be error. And then we return to normal. My mind wandered there. I'm sorry about that. Let's try and compile this and then fix the mistakes I have made. Three, 5. Oops. That's a system crash, folks. We ran out of memory. In order to read your comment, I have to type some dummy stuff here. I have an idea for a lang. The copying trace stack, is that any chance to be good? I don't quite understand what you mean by copying trace stack. So you're gonna have to explain that. Oh no, it's that. Yeah. Compiler will build a tree of copies of every or some variables, like pointed to person to copy of. Maybe I understand a little bit more what you're talking about, but I don't exactly know what the purpose would be. You're talking about some kind of tree, keeping track of who copies whom. Oh, you mean, oh, instead of copying. Oh, maybe you'd have to build that. I don't think that would. I don't think that's a performance problem. Or, well, at least my philosophy on these things is that real performance always comes from the human doing the work. And so that's what you want to optimize for. Is the human doing work here. Okay, we're gonna edit the commands file. we're going to add some commands. One of them is going to be clb in sdbean clb.pb. Another is going to be a funde sdbean another is going to be dd3. Let's have an example as well where the path is wrong. I guess clb debug would be this. And then we need one with args. No, what I mean by human performance is, I mean the work to make something will be fast because a human engineer spent time and effort profiling and optimizing and seeing what's slow and making it better. And so what you want to do, I mean, it's useful to, like, for example, be able to produce better code. But I think the unexploited stuff is, how do we look, instead of saying how do we make compilers that can take badly written code and make it fast anyway, I think a lot more mileage is to be had saying how do we make it easy for somebody whose intention is to write fast code. How do we make it easier for them to achieve the result they're after in less time, as opposed to how do we take a not so good programmer and take what they've done and somehow magically make it fast. So product shell. If I type interesting. in your language list, you should have put Odin. Now I'm confused. I don't know. I don't know. Oh, so it's not loading anything from the file text. this is goofy. Clearly there is stuff in this file. So like, what's up with that? So we build the thing, we run this guy, we open the terminal, we go in here, we run the shell. What? Oh, it's because I'm being stupid, yo. I'm the stupid one. Look at this. In here, there's now a commands.txt. I need the button to press so that we get, you know, spectacular music. Okay, let's try this again. Arca, B-term. Whoa, interesting, interesting. That was much more activity. I like that. What if you are not able to name variables and this would be automatic? Proceed by interactable writer. Hold on. Like texted as part of the compiler. Well, some form of more interactive compiler editor thing, I think, is definitely a good idea. I sort of have too much on my plate to pursue something like that. I know I've spoken to Negate of CUIC and TB fame that that he wants to do something like that. Ah! Got no history, so I can't go back up. So we add all the users. I think in a bit I'll have to go eat some more food, and so we'll have to end the stream. You have a question. As a Lang developer, what comes first, stack or control flow? Good question. I would say neither. When I started, there was no. Let's think here. I mean, probably stack if you wanted to be specific, because in the early days, like the really early brevis, you couldn't. There was no like manipulating memory yet. It was everything was by value, and so yeah. Oh, and then you're not doing register allocation either, so it's just everything is on the stack. But I wouldn't even think of it as that way, because the stack there is just making possible the thing you're trying to do. Like, it's not, you can't actually use the stack for anything. It's just where the values live. And that's just a technicality. I mean, it could be, they could live somewhere else in memory. So yeah, probably the stack first, and then, but you very quickly want to do control flow and loops, because that's the interesting part of programming. Past 4:40. Interesting. Why do we think in terms of functions? Because that's a useful way of thinking. Whoops. Alright, I don't know. Maybe I'll solve this bug quickly. But I want to eat food, so I'm going to end the stream here. There will be other streams in the future. So maybe tune in for